don't think, but I don't think we've lost it. So you had this idea that we've lost that psychic stuff. I think it's absolutely there, and I think it's neuroscientifically defensible that it's there, but that language actually suppresses it. So
yeah, atrophies it.
It doesn't atrophy it.
No?
It's like you can actually use. So there's this cool result from this guy in Baycrest. His name's Morris Freeman, and he's a neurologist there up in Canada. And he noticed in his stroke patients that if they had lesions here, so their stroke kind of messed up this area here, left frontal orbital area of the brain in the cortex, that they seemed to be more psychic. Like he didn't know how to explain it. So he did an actual experiment where he tried to get people to move with their minds an arrow on a computer screen. So there was no mouse, there was no way to move it. They just had to look at the arrow and say, move to the left or move to the right, and wish it to happen, and using their intention, right? So the people who had the strokes there were able to do it statistically significantly. People who had the strokes over here were not able to do it.
So can I pause you here? What was actually moving the cursor?
So he had a random number generator hooked up to the generator.
Okay.
So the cursor was kind of like shaking, and the random number generator would make it deviate to the left or to the right. So the person was effectively changing the random number generator.
How often?
Enough so that it was statistically significant.
What is statistically significant?
So what you would do
numbers?
is, you would have a control. So
Right.
you have the try period where you say to the person, try to move it to the left, try to move it to the right. And then you have the control period where you say, read a book, like you're not trying. And you compare the distance and the amount of time it's spent in the intended direction to the reading a book time. And if there's statistical tests you can use to determine whether it was spending time in the intended direction more often when it was intended.
But how much more often?
A number that's statistically significant. So I guess, it's like imagine...
Like 5%, 10%?
Oh, I forget what the actual quantitative number...
But that would be interesting to know.
I totally would. I just forget.
Whether or not it would change with different humans.
I agree. But then he replicated it. Instead of looking at stroke patients, he used transcranial magnetic stimulation, which turns down activity. So he put that over here. So he's putting that over the left area, and to turn that down. And again, these are not people who've had strokes, just regular people, you and I. They were able to do this with their minds. So it's just sitting there. His explanation is that the left orbital frontal area we know that it inhibits the right